It's all naturally occurring. That's
Yes.
not from the plant.
That shows you how conservative we are at the nuclear plant, is we will pants you if you get a little bit too much background radiation due to static cling. It's time for some more smarter every day. Specifically, refueling a nuclear reactor, something you do every 18 to 24 months at the nuclear plant. For those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry, from engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Let's see.
Is that a hot rod?
It is very hot.
That's a very hot rod.
Yes.
Oh, one thing I know from doing a bunch of refueling outages is crane operators up here on the refueling bridge. They're very professional, extremely good at what they do, but they kind of speak their own language sometimes. It's fascinating.
Back up out of the water, wouldn't no longer be here. None of us up here.
Really?
Really.
Hey, it's me.
Yes, that's why you have that much shielding. You're under upwards of 23, maybe 30 feet of water between the nuclear fuel and you. Provides you all the shielding you need.
Welcome back to Smarter Every Day. I am so incredibly excited to share this video with you. I have never experienced anything like this. I've wanted to learn about nuclear power for years, but I purposefully kept myself ignorant. Like I didn't, I deep dive into aerodynamics and all material science, things like that. But nuclear power is like this thing that I didn't want to approach until the time was right. And
Well, look, I'm happy to help you out.
The time is right. We're about to learn about nuclear power by seeing it and by meeting the people who are making nuclear power. And we're going to walk inside an active nuclear power plant, not just like on any normal day. We're going to walk in to a power plant on the day that they're refueling it. They're taking old fuel rods out and putting new fuel rods back in.
So huge props to whatever site this is that allowed him to do that. And I'm not just talking about going in with a camera crew. He needs to be trained to get on the refueling bridge. There's at least a couple of levels of general employee training that's required to get you in there. There's one on all the plant policies and procedures they let you on site in general. And that includes things like complying with security requirements, industrial safety, and nuclear safety procedures and processes. The other one is they need to train him how to be a radiological worker in order to enter the reactor containment building during a refueling outage. And there's probably some site-specific stuff and other specialized programs that he needs to do depending on what site he's going to. And that can take the better part of a couple of days to a week, depending on his experience level. There are ways to fast track it, but the point is you're not going to go in and take a 5 to 10 minute course. It's going to be a whole deal, and you're going to have to take a test, both a physical test and a practical test for dressing out in protective clothing.
And we're going to see how they do that. And it has totally demystified nuclear power for me. Like, this experience just changed how I feel about a nuclear power plant being just down the road from where I live. It's awesome. So this is what I would ask of you to do for you. If you would just watch the video as if you're there with me and we're walking around and we're asking the questions together. And
of course, and outages are a fun time because you get to see things taken apart that you wouldn't take apart while the reactor is operating. So you get to see and learn a lot of new things. That's where a lot of new operators and engineers really learn their job quickly, is by taking part in a refueling outage.
Experiencing it and give yourself some grace, because there are moments where I have no idea what's going on and I'm just asking questions. And I think it's okay.
There are some outages that you have no idea what's going on if you're experienced. So yeah, it's something you kind of have to sit back and look at the big picture project schedule and overall plan to understand. And that's talking from someone with experience. And outages are run a little different depending on where you are. So what I see here might be completely different from the site that I've worked at.
To not know what's happening and then just let it happen. And then later on in the video, we'll understand more about it. So this is a really neat experience. I hope you really enjoy it. This is unlike the access most people get to the nuclear industry. So
yes, a lot of this stuff you need to be an employee. And I'm actually, again, kind of surprised they let him do that, which is awesome. It's props to whichever site he's going to.
It's very, very special. And I want to thank the people that let this happen. This is the culmination of months of coordination.
Brown's Ferry. Okay, so the same one that he went to and got some of this training before in a previous video.
And training and people working behind the scenes to get...
I've never actually been inside Brown's Ferry. I just happened to drive past it, simply because I have family in North Alabama.
This very special look into a very special place. You can't just take a camera here. You have to have the proper training, and a ton of people made this happen. I'm so grateful for that. But yeah, let's go to an...
And he's not kidding. It's a big process to get people trained, and not just him, but his camera crew also need to be trained on this as well. So however big his media team is that are actually going into the site, they all need to get trained on that as well. And there's probably various rules about what you can photograph, what you can make a video of at a nuclear power plant. It was all super strict, so there might be a lot of jumping around we see here.
Nuclear power plant and learn about nuclear power in a very real way. Let's go get smarter every day. So something's about to happen that we've been wanting to happen forever. We're gonna get to go to a nuclear plant, and this is my friend Philip, who forever I've called him Jimmy Neutron as long as I can remember.
Jimmy
and the
Neutron.
thing about Philip is he's very moderate, very level. How would you say?
Not very expressive.
This is angry face. This is also his happy face. This is his excited face, and that's kind of who you want.
That's pretty realistic at the nuclear plant.
Working in a nuclear plant, I feel.
Yeah, I'm the most boring man you'll meet. I have to get extra medium shirts.
Extra medium? Okay.
Yeah, that's nuclear plant type of humor too. All right. Yeah. One of us.
George, we're going to go to a nuclear plant. You excited?
I'm so pumped.
All right. There it is over there. Where are we at, Philip?
We are leaving the training center, and you are just east of the plant.
What's the name of the plant?
This is Browns Ferry Nuclear Plant.
All right. This is the third largest nuclear plant in the United States, correct?
That's a big one. It's a 3-unit site. Bigger than the plant that I worked at, which was just 2 units.
I don't know.
Used to be the second. Now that Vogel has units 3 and 4, Vogel is the largest in Georgia, followed by Palo Verde in Arizona, and Browns Ferry would be third now.
It's one of the biggest ones.
I believe it is, but you guys have 3 units, correct?
We have 3 units. We are the only plant that has all 3 units under one roof.
That's different. One roof meaning one reactor containment building. So the design criteria would have to be that containment building could withstand all of the energy within of those 3 nuclear reactors, simultaneously depositing their energy into the reactor containment building, whether it be a form of loss of coolant accident or steam generator line breaks. So it's quite the rugged structure.
Watch your step. Yeah.
Yes, even on like steps, people walking outside, because that's where the OSHA recordables happen. It's things like people falling down the stairs and people getting their fingers jammed into a building in the office building, not in the radiological controlled area, not in the nuclear part of the nuclear plant, or even the protective area. It's around the office buildings or when these sorts of things happen, because this is where people let their guard down. And hey, I mean, when's the last time you filled out a job safety plan from walking to your car or walking to your office?
At nuclear plants, I've heard, is over the top.
Oh, yeah. We have rules on how to climb a flight of stairs.
Really?
Yes, 3 points of contact. And you will be scolded by that, rightfully so, if you are not maintaining 3 points of contact.
Crazy. But people rarely get hurt, so I guess it works.
Industrial safety, the OSHA recordables, their RIF rates are at an all-time low compared to other industries due to these seriously high standards. And I'm just talking industrial safety that you see at any other facility of this size, not even the nuclear part yet.
There you go. What's up, Bill?
Hey, how are you doing?
Doing well. All right. So this is the security.
It is. This is our Westgate house. That's how we get into the plant.
Okay. Cool. Sounds good. Bill, what's your deal here at the plant?
I work with a distribution shop right now. I've worked here for about 15 years. I'll spend some time in operations as a licensed operator. And
So is this where I need to cut off the camera for security stuff, or we go?
Typical career path, works his way up and becomes a licensed operator, just like I did, and now he's over a maintenance shop, the instrumentation and controls shop. That's good. A lot of organizations want to send people to licensed operator training. You get all the additional nuclear safety and nuclear management training and the experience of running the site from the control room, and then you typically transfer into management roles in other departments. For instance, I became a licensed senior reactor operator myself and did my time on shift, working rotating shift schedules, and then transitioned to a program management role using the additional knowledge and management training and experience that I got while on shift.
I'll cut the camera here.
So we just went through a lot of security that I'm not allowed to show you.
yeah,
And it's
Well said.
intense. There's a lady that you'll probably see on camera here in a minute. She's got a rifle. So I feel comfortable.
Yes, that level of security is typical at a nuclear plant.
That's pretty good.
well, we want to make sure everybody stays safe while they're working here. We don't want any issues, the wrong people being here, right?
So when you come into work every day, you've got to go through that.
Yes, sir, every day.
Yep.
All right, good. All right, so Bill, what do we have here?
So these are our two buildings. You'll see the larger building over here is our reactor building. Our shorter building over here is our turbine building. Reactor building's got the reactors that are housed in there. It's really a secondary containment, just in case something went awry. And then our turbine building over here.
Primary containment, talking about the reactor vessels itself as well as the bioshielding around that. Though I'm not exactly sure what the layout of that would look like at a 3-unit site, but we're just talking about it. He's talking about additional layers of radiation protection.
We got our turbine and our generator where we produce our power, and then you can actually over here see all the lines that are coming out of the plant. That's where we supply 500,000 volts to the valley, which goes to the substations out there to our homes, really. Neutron.
The reason why you step it up to 500,000 volts, the generators themselves are probably only at about 25,000, but it's for long-range transmission. The site that I worked at the switchyard was at 345,000 volts, but the power doesn't have to travel as far. I mean, here we're talking about North Alabama, less populated area. So, yeah, I believe go ahead and set up the transmission lines to a higher voltage.
Electrons.
So the reactor's actually in there.
Yep.
And then this is the generator turbine, all this.
Yep.
And then that's where distribution. The security stuff, it's pretty serious.
I think so.
Yeah.
Yeah, it's
You take it seriously.
Am I allowed to say what we had to do to get in the building?
I mean, yeah, you can. I think so.
Biometrics.
Yeah.
Biometrics and that was, and not normal biometrics. Browns Ferry Nuclear Power Plant is run by TVA, the Tennessee Valley Authority. It's a public corporation created during the New Deal coming out of the Great Depression to help manage and protect and use the Tennessee Valley's vast waterway system as effectively as possible. And today, it's become a major energy provider in the area, pushing power out to over 10 million people. This plant, Browns Ferry, was constructed in the 1960s and 1970s and is a huge deal for my local community. We headed down to what's called dosimetry, where we would be checked in and given devices called dosimeters that would track our exposure to ionizing radiation as we move throughout the plant. This video is a part of a deep dive series on nuclear power that we're doing here on Smarter Every Day. In a previous video, we learned about these dosimeters when George and I had to...
And if you want to see my reaction to this one, I'll put it down in a comment below. I really like this series thus far. They go into a very in-depth look at this sort of thing that most people outside the industry don't get to see. It's a really good series.
Radiation training in order to enter the plant today. So if you want to go deeper into nuclear power...
Just And this all makes sense. He might as well stick with the site that he did all that for the purpose of the other video. Not to mention, I think he's from the area, so it saves him from having to travel.
This series, it's pretty cool. You can subscribe on YouTube if you're into that, or you can sign up for the email list on smartereveryday.com, and when the new videos come out, I'll send them to you. In an earlier video in the series, we explored EBR-1, the first nuclear reactor to generate electricity and put it on the grid, and there's so much more that we're going to learn about in this deep dive, from how we handle radioactive materials to future nuclear technology to how to deal with nuclear waste. In upcoming videos, we're going to explore all this and learn everything we can about this important energy option. But right now, let's get back to the plant.
How's it going? I'm Destin.
Destin, nice to meet you.
Nice to meet you.
Okay, just one at a time. I'll need you to step into,
This?
yes, the DIM 5.
Okay. Sounds good.
Little room here.
And so what are we doing here? You said your name was?
Amanda.
I'm
As far
Destin, yeah.
Yes.
Background count.
Radiation protection. I'm the one that issues dosimetry.
Oh, great.
Yes.
Awesome. So I go right in here?
Step in, face the wall, or you can.
Face the wall?
3, 2. Be careful stepping out. Clean. This little device, as far
You have to walk through one of those every time you leave the plant. And I say the plant, not just the radiological controlled area. There's one within there too. So if you go in the radiological controlled area every day, then yeah, you're going to be stepping through these a lot.
it's your dosimeter of legal record.
Okay.
Yep.
So when this is red, it has dose on it, and when you log in, you'll have a self-reading dosimeter. It's real time,
Okay.
okay?
And so I'll carry these with me at all times, right?
Well, when you go into the RCA, you'll log into the SRD, but this will be on your person all time,
Okay.
okay?
Got it.
Yep, you keep that on you all time, usually near your badge and on your upper body, and it's something you just keep with you, and it is designed to track chronic dose, whereas the EPD is to measure acute dose and dose you're getting while you're actively in the RCA, like she said. But your chronic dose is measured outside of the radiological controlled area, which is quite conservative. So dose that you would get essentially from your job site that's not in the normal controlled area is going to get measured. Now, you're not going to get very much from that, but still, it's another example of the nuclear industry being conservative. And you do switch those out, but it's typically every 6 months. So the Radiation Protection Office will keep track of how much dose you've received your entire career. And if you're visiting other sites, that's one thing that it takes into consideration is your radiation protection office from your site would communicate with the office from the other site just so your entire dose record is kept up. It follows you. It's kind of like your medical records.
And so do you track this for everybody in the entire plant?
Anyone who has to go in the RCA, yes.
Wow.
Yeah.
So yes, that includes permanent plant employees, contractors, and I guess I'm going to say VIP visitors that would get to go into the RCA in this case.
Okay.
About 2,000, and during an outage, it could be anywhere from there to 4,000.
Yep, that's typical, bringing in a whole bunch of extra vendors during an outage. There are people whose entire career is to go from plant to plant to assist during a refueling outage.
That's amazing. So while we're waiting on dosimetry, this is Angela.
1,
Hi.
2.
So what instructions did they give you?
No, they just said just to be with y'all, just in case anything happened and we needed to escort y'all out.
You're more intimidating than I expected.
Really?
You are, yes.
Thank you.
You're welcome.
Doing your job well.
Ma'am?
You can hold this.
Oh, thank you so much. So this is my dosimeter.
Dosimeter, yes.
I should feel a bond with this.
Yes.
Okay, thank
Do
you.
not lose it.
Okay, great.
Yeah,
Thank you.
you don't want
Are
to
you
lose
excited
that.
to bond
No.
with your dosimeter?
That's a mess. It's mostly paperwork, but it can turn into a real pain if you lose your dosimeter or if you lose your badge, anything like that. And you get to get escorted, and at all times, if you were to lose one while you were in the radiological controlled area, basically they escort you out just to make sure nothing else you don't get an unmonitored dose.
To meet it.
There's a lot of stuff.
Yes.
Good thing I have 3 chins. Start clipping stuff to my chins.
And depending on where you're going to need to have FME tie-off. That's foreign material exclusion, so they don't inadvertently fall off into, say, the refueling cavity.
I have the beard.
So you have the beard? Yeah.
You excited?
I'm very excited. Did you see me do a little dance just then?
I like this guy.
Yeah.
It's good to have people excited here.
That's good. I'm seeing a lot of beards, man. I don't have a beard. Do they issue you that beard?
Yes, they do.
Mentions beards. If you're in the control room, you're not going to see any, at least the people that are licensed operators, because you need to have SCBA training, because there are SCBAs scheduled in staged by the control room, so you can be there and don your SCBA in case, I don't know, there's some sort of airborne contamination hazard. Not typical at a nuclear power plant, but who knows? There could be an accident in a nearby chemical plant. The point is, it's prepared for that you can still stay in the control room even if a hazardous atmosphere presents itself. Within reason, there are control room evacuation procedures, but yeah, one of the things, if you work in the control room, you're not allowed to have a beard, so you can still wear SCBA if you need to.
He just got a mustache. I don't have facial hair. I don't feel like I can be here. Bill thought I might
You'd be ideal in the control room, buddy.
find it interesting to check in some of the people in the executive offices, so we went upstairs and met Lionel Locke, the safety manager. What's up, man?
How you doing? I'm Lionel.
I'm Destin. Nice to meet you.
Nice to meet you.
Yeah, pleasure. So Lionel, I have heard a word over and over ever since I got here, and it's outage.
Yes.
I've heard the word outage. What is it? What is an outage?
An outage means that, so the plant, when it's running, it's online. That
Okay.
means we're making power, we're putting it in the transmission system. We got to turn the plant off, cool everything down, open everything up so we can fix the valves, fix the motors, and do the maintenance of the plant. So we're not creating any power, we're not generating any electricity. But this is a monster. It's 3 units, and it's a challenge to manage not just the outage, the unit that we have an outage. We still have 2 reactors that are running.
Okay.
So it's
You're going to want to stagger outages so you're continuing to produce electricity at some level of capacity. At the 2-unit site I worked at, we staggered them. And based on the schedule with there, it was 18 months. So the math worked out that every 3 years you have 2 outages, both in the spring and in the fall when demand is low. You wouldn't want to have an outage during a summer or winter. But yes, there's certain types of maintenance, not just refueling, but there's certain types of maintenance that needs to be done. It can only be done when the reactors are not just shut down, but completely cooled down and depressurized. That takes multiple days. An emergency shutdown takes a few seconds, but to fully cool down and depressurize, that takes days. And there's certain maintenance that has to be done periodically that isn't really so much as maintenance, it's more of testing that is required per federal law. So you can't defer some things during an outage. So it isn't just refuel the reactor as fast as you can. You have to do a lot of those maintenances. Those are called surveillances. And those surveillances are done in accordance with the reactor's technical specifications, which are in agreement between the plant operating company and the federal government that of how you will operate the plant safely. There's a whole section of the tech specs on surveillances.
always a challenge, and it's a good team. It takes a solid team to manage all of this. Some of the other sites that may just have one unit, a little easier for them because they just got that one unit in an outage. That's all they got to focus on. But we're still producing power with 2 other units.
Yeah, and producing power with 2, it's usually one's online and one's off is what I'm used to. So with 2 online and 1 off, that's a bit of a different mindset. So it's like, okay, you have an outage, but you're still mostly online.
So there's 3 units. So Bill, there's 3 units here?
Yes, sir.
Okay, and so what are the unit 1, unit 2, unit 3? Is that what you call them?
Yes, sir. Yeah, each operating at about 4,000 thermal megawatts, putting out about 1,350 megawatts electric to the grid.
Each one of those are similar size to the plant that I worked at. So this one's bigger, a full 50% bigger.
What's going down for the outage?
Right now, Unit 2's down, and we're refueling that and performing all the work that Lionel discussed, and Unit 1 and 3 are operating.
We are in a refueling outage. So refueling outage means we are literally taking the spent fuel out, putting in the spent fuel pool, and we got around 330 new assemblies that we're putting inside the core. So or you have your coal plants that have railroad cars constantly coming in with coal. We can run 2 years off of off the nuclear fuel that we put in.
Okay, so 2-year fuel cycle here. Good. That's better than 18 months. That also works better when you have 3 units. The math would work out a bit better for keeping 2 units offline or online.
For this outage.
And that's happening today.
Right now, as we speak.
So this is a big day to be here.
Yes, it is.
And this is why you brought me in on a Saturday.
I did, yes, sir.
Thank you so much, man.
Oh, yeah. The whole 9 to 5, Monday through Friday. Yeah, that's not a thing during an outage. A typical schedule during an outage, at least when I worked, was 4 on, 1 off, whether it be day shift or night shift, and it would be 12 hours. So you'd get quite a bit of overtime. Of course, since I was in management, I didn't get the time and a half pay, but hey, to each their own.
Lionel, thank you.
Appreciate it.
Is this a fuel bundle, Bill?
Yeah, actually, that is a mock-up of a fuel bundle.
So
Yeah.
this is what we're refueling today?
That's right. Yeah, this is a Natrium 11, I believe, is the style on this one.
Okay.
So these are your fuel rods. You got a good view of the fuel pellets here, also.
So these
yeah.
are the pellets. All right, and so we're pulling these things out with a crane and putting them back in?
Correct. Yeah.
So these fuel rods are where the magic happens, and I want to talk about.
So one thing is they mentioned 330 of them. The plant that I worked at, the number was 193, but these fuel rods are a little smaller, and that's typically for boiling water reactors versus pressurized water reactors. So ultimately the weight, the power generation is all about the same, but they're a little smaller in boiling water reactors.
So much. Someone actually sent me a book after one of the first videos in this series. I opened the book. It's made like a long time ago. Of
course.
Sure enough, the exact reactor for Browns Ferry Nuclear Power Plant is in there. Look at that. Those are the fuel bundles. And I have been researching this so much. The thing specifically.
And yes, when I went to school, you use textbooks that are about that old. And they were old when I went to school, using stuff from like the 70s, because that's when a lot of this stuff was designed.
Talk about is the difference between a boiling water reactor, which is what Browns Ferry is, and a pressurized water reactor.
Which is
but we
where I
just
work.
don't have time for that in this video. In a future video, we're going to talk to an internationally recognized expert named Bill Williamson. This guy knows so much. We are going to learn this stuff, but this video is just not the place to do it. But for now, let's go talk to the guy that's over this nuclear power plant.
Trying to hide from us? I got some people that wanted to meet you, Quinn.
What's up, Quinn?
Hey man, good to see you.
How's it going?
Good.
Yeah. So I'm Destin.
Yeah.
Yeah. We met during my training, right?
Yeah.
That's not uncommon, the plant manager's office not having any windows.
All right, so I met Lionel, so far safety guy, and you're the plant manager, right?
Correct.
So I learned about the outage. So we're in an outage.
Yep.
Unit 2 is down. Is that what that means up there?
Yeah, so one of the benefits of the plant manager's office is you have megawatt meters for all 3 units.
Is that real?
Yeah.
Absolutely real? Okay.
Okay, that's a little different. I haven't seen that at any other plant manager's office. I mean, really, that's as far as who's actually responsible for that. I mean, yes, the plant manager, all the operating crews would report to the plant manager, but it's really going to be the shift manager of each operations crew that really oversees each megawatt. But for the longer strategic vision, yes, it's still going to be the plant manager's job, but I've never seen these meters in a plant manager's office before.
You can see 2 is down, 1's at 100% power, 3 is right about 91% power right now.
I don't know, I might want to get those looked at. It looks like Unit 2 there is producing negative, which it could actually be using some electricity, but obviously you wouldn't see it there to run all the systems, the support systems and auxiliaries while the unit is down. I'm not sure what phase in the outage they are, at least as far as the secondary plant is concerned.
We're coming back up to 100 from the outage that we talked about.
Okay, so how long does it take to come up to, what is 100% in terms of megawatts?
About 1,300 on a good cold river day.
Okay, he's talking about on the grid specifically, which is different from the reactor. The reactor is going to be closer to 4,000.
What do you mean by cold river day?
So when the river's cold, it allows us to improve our vacuum in the condenser, which improves our megawatt output.
So really, a nuclear power plant is a big Carnot-style heat engine. Carnot being the ideal case, of course. But how you improve your efficiency is you make your T hot, which is the reactor, hotter, or you make T cold, which is the reservoir, in this case the Tennessee River, colder. So That's why he's talking about on a cold day, yeah, you get a little bit more thermodynamic efficiency from this place.
Really? Yeah, it's temperature dependent.
So tell me, when you see these dials up here like this, what does that make you feel? Like, is
The one on the left makes me happy.
okay? Yeah.
And the one in the center is expected, right? So you have to, every 2 years, you have to take a unit down to change out a third of the nuclear fuel. And that's what we're doing. That's what you'll go see here in a little bit. So they're moving fuel in and out of the core.
And the one on the far right, are you comfortable with that?
No, I like it to match the one in Unit 1.
So what I've been told is that
So Unit 3 is not at 100%. Interesting. Could be something else going on.
nuclear plants, like, you want it to be boring.
Yeah, absolutely. Absolutely. Hot, straight, normal, 100% power, just sit there.
Really? So steady state.
Yep.
Steaming and dreaming.
How long does it take to bring a plant down for an outage, and then versus how long does it take to bring it back up?
So the way we do it for refueling outages, it takes about 12 hours. We start around 9 o'clock in the morning, derating in steps, and then we can go in at various. So
This is your slow, non-emergency, controlled ramp down, not a reactor trip from 100% power.
WR, which is boiling water reactor, which means we have contaminated systems throughout the whole station. So there's areas that we can't access at 100% power that we can't access at 40% power.
So the difference he's getting at is boiling water reactors. So boiling does occur within the reactor vessel, and it's hydraulically coupled to the secondary part of the plant. So yes, you're going to get some trace amounts, and I say trace relative to the intensity of a nuclear reactor that you would get in the secondary or turbine part of the cycle, in contrast to a pressurized water reactor, which is going to be separate. So there's not as much cleanup you have to do to the secondary turbine side of a pressurized water reactor. It's one of the advantages of pressurized water reactors over boiling water reactors.
We'll go in at 40%. We'll come down from, like this last time we were coasting, we were down around 80% power because our fuel was running out. So we were coasting down from 100 down to 80. And then we started our outage, so we came down to around 40.
That's typical. In a way, that's actually good, because that means you probably didn't have to take a forced outage. They keep saying refueling outage, but a forced outage is you had to trip the reactor for some reason. And at that point, your goal is basically to get the unit back up to 100%, fix whatever broke, and get it back up to 100%. There's also the term maintenance outage that's thrown out there, and usually it's going to be coupled with a refueling outage, and sometimes you'll just have a longer outage. A lot of refueling outages are typically done with a span of 30 days, but some longer maintenance outages, say you're replacing a steam generator, that could take something like 60 or even 90.
Percent power, took heaters out of service, did some inspections, looking for leaks, looking for stuff we would need to fix during the outage.
He's talking about feed water heaters that preheat the secondary part of the nuclear plant.
So that we had the right scope for the outage.
So you start ramping down.
Right.
You take an assessment because you can go more places.
That's right.
And then at that time, you start planning for the outage. Do you keep it at 40%?
No, so we come down to around 20% and then insert what we call a manual scram.
Okay.
What is it?
That's going to be a reactor trip, and that's typical. You want to get less than 20%. It also eases the inertia on the system. It's the nuclear equivalent versus slamming on the brakes at 20 miles per hour versus slamming on the brakes at 100 miles per hour. You're way less likely to break something.
So there's 2 big red buttons in the control room. You can see those. An operator pushes those, and all the rods go.
At the plant I worked at, it was a pistol grip switch that you turn like a key.
BWR, they come in from the bottom.
Yeah, so bottom water reactor. Not really.
Immediately shuts down the reactor.
Okay, so what is a BW?
Yeah, we're talking less than 2 seconds.
So boiling water reactor means it's designed to have boiling inside the reactor vessel.
Okay.
In a pressurized water reactor, you're not supposed to have that. But no, it doesn't. And there are various stages of boiling, so you're talking about full bulk boiling, which is probably what you mostly think of when you think of boiling once you get your tea kettle set up.
Pressurized water reactors don't have mass boiling in their reactors. They have nucleate boiling, which means tiny little bubbles form on the surface of the fuel and then immediately collapse.
Literally what happens when you're boiling a pot of water and you're watching a pot trying to make it boil for some reason, and you're just seeing the little bubbles rise and never making it to the top. So which is a lot further away when you're talking about heat of vaporization, especially at these temperatures and pressures. There's a big difference between nucleate boiling or bulk boiling or film boiling. There are various levels of boiling between nucleate and a full-on boiling water reactor.
Pressure is so high that it doesn't turn to boiling.
Okay.
Boiling water reactors are at a mere 1,000-ish psi compared to a pressurized water reactor at about 2,250 when you're fully pressurized.
Essentially are at saturation conditions inside the vessel. So we run around 1,000 pounds, 1,000 psig, which equates to about 570 degrees.
Yeah. So even though it's called a boiling water reactor and the other one's called a pressurized water reactor, you're still boiling under pressure here.
Yeah. But we're designed.
You want it to be hot enough that you actually make something worthwhile. Again, back to the Carnot example. You're just around saturation versus being subcooled.
Mass boiling. So we have a huge pocket of steam inside the pressure vessel, which PWRs don't.
Okay. Kind of like the old locomotives, the steam locomotives, they had a big reservoir up top of steam.
Yeah, right.
Yeah.
That's right.
And so what temperature will that steam be? 570, you said?
Yeah, about 570.
Yeah, the moderate temperature.
So they're also a little colder. The steam generator, the steam is going to be comparable, but the reactor coolant system is going to be around 620, 630 core exit thermocouple temperature.
Yes, that's right.
So these are literally the steam tables.
Yeah.
Yes, you have to get those out, and you have to use these manual ones on your licensed operator exams. You can't use an app on your phone during the test. That is a requirement, and you could thank the 3 Mile Island accident for making this a requirement. Every pressurized water reactor, the 3 Mile Island scenario is going to be one of your scenarios because it's a pressurized water reactor.
Let's see. Saturated steam.
Yep. You look at the tables, and then you fold it out to look at the Mollier diagram. Because you're going to get that one question. It shows up on just about every single regulatory exam, rightfully so, because, again, that was the 3 Mile Island scenario. You're either going to get that, or you're going to get something that looks like that in the simulator. Or both. I mean, you're tested a lot.
Because every nuclear plant is just a steam plant, right?
Correct. Ultimately, you're creating steam to drive a turbine. So about 550.
So you went to...
You're just using some hot rocks.
PSI.
I like that they're including this in the video. It's great.
Square inch. You went down to 1,000, right?
Complete with it blurry, complete with the shimmer, because that's realistic. You're going to look at it, and it's going to shimmer, and trying to keep your place and keep your fingers in the right spot. That's literally the hardest part. None of this is hard at all from an engineering perspective. At least when it comes to using this, it's just losing your place. And if you're making this calculation for real, well, you don't have to just use steam tables. You can use apps in the real unit. And you're going to get a peer checker. You're going to get peer checked. So, and there's one person in the control room whose job it is to do these sorts of calculations. That's known as the shift technical advisor, typically, which was one of the jobs I had on shift. That's pretty common. Nuclear engineer with a nuclear engineer that's also a licensed operator. You don't actually have to have a full nuclear engineering degree, but you need to have some level of educational requirement. Compared that licensed operators, you technically don't need even a bachelor's degree for that, but you would need a fair bit of on-shift time experience or equivalent military experience before that if you didn't have the educational background.
That's where this BWR operates. And then the temperature that water boils is in this area.
About 550, yeah.
About 550.
And that's a similar pressure for the steam and temperature for the steam generators. So ultimately, it's similar-ish thermodynamic efficiency. It's a different structure than the reactor vessel. The reactor coolant system is what's heating up the steam generators in a pressurized water reactor.
And so it's just physics.
Yep.
Yeah. Just
so
physics.
We're going to see Unit 2 open, which makes sense because we're in an outage.
It's flooded up too. You'll be able to see. So as a part of refueling, We take those concrete blocks off, we take the drywall head off, we take the reactor pressure vessel head off and put them on stands, and then we flood the water level up equal to the spent fuel pool, and then we remove some shield blocks, and then we just lift the fuel up, move it over, and put it down. So it's one big pool.
Thanks, Quinn.
Thank you.
That's a key point. You have additional water than what's normally kept there for additional margin, both in terms of radiological safety and in terms of heat up safety. Because a lot of this fresh fuel, it's going to be hotter than what you typically see in a spent fuel pool. It just hasn't had as much time to decay yet.
We've got some hard hats for you, some safety equipment for when you get out in the plant.
Great.
Oh, we get a lanyard.
That you do.
Bill's making me do more training. What am I doing?
You're doing some form material training, so one of the things with the core, it's open, right? So we want to make sure that there's nothing that could potentially drop off you and fall onto the core. We have methods of retrieval, obviously. And
that's a big deal. And the reason why there's a form material exclusion program is because Fermi Unit 1 suffered a fuel damage, a meltdown, and to use the journalist terms, due to a foreign material exclusion event or an FME event. So everyone in any of these FME zones, such as above the reactor cavity during an outage, is going to need to be trained in how to properly secure their tools, what types of tools are prohibited, and what to do if they see a foreign material intrusion event. Exclusion is the name of the program, but intrusion would be when the bad thing happens.
if something happened, we'd be okay, but what I want to make sure is that you understand the rules and regulations associated with going over the core, and as far as form material goes, we don't want to drop something.
So I don't drop something. I'm taking training so I don't drop like camera pieces or anything in the core.
That's right.
So I guess the point is, I'm not just going over an open nuclear reactor. This is a coordinate.
There are certain components like tie wraps, at least at the plant I worked at, that were straight up forbidden in the reactor containment building.
And we're going to have to like be careful about how I hold things, right?
Yeah, absolutely.
Okay, cool. Thank you.
Yep.
Okay, time to dress out.
I don't feel naked, but I feel less clothed.
They actually refer to those, I've heard those scrubs actually referred to as modesty garments. And they're also what's given out if you become contaminated and you have to say, lose your pants.
Well, you are. Okay, cool. So where are we going exactly? We're going over the fuel?
Yeah, we're going to go on the refuel floor bridge. So,
what is this? Can we look at this?
Yeah, actually, that's a really good picture right there. So what they're doing is, this is a picture of our core uncovered right here, and
that's where we're going.
Yeah, there's a bridge that's sitting over there, and there's almost near about 100 feet of water that's over all that fuel, and we're gonna ride.
So quite a few assemblies still in there. I don't know if they're offloading and they're just starting, or if they're reloading and they're almost done.
A bridge, a crane, essentially, that goes over there and moves the fuel.
Is that what is happening here? Like, I'm seeing a camera. Is this on the crane that's moving?
Yeah, that's on the mast on the crane. That's all the way down. Right now there's another portion that you're not seeing, the spent fuel. That's where they're at right now. But there's a mast that goes all the way down into the core, and it'll latch onto the fuel, and we'll move the fuel.
So this
highly specialized profession, highly specialized individuals that operate that crane. And at least at the plant that I worked at, you are required to have someone, a licensed senior reactor operator, be on the refueling bridge during a refueling operation, what's known as the core load supervisor. That job, let's just say it wasn't for me. Basically, the main reason why I didn't care for it was because you would have to be on that refueling bridge for upwards of 4 hours straight sometimes, and I can't hold it that long. But yeah, and there isn't exactly a place to go while you're there, because you're in a radiological controlled area. No eating, no drinking, and no going to the bathroom. That's the bigger hazard that's up there, at least to me. Forget the radiation part.
Blue that I'm seeing, is that Cherenkov radiation, or is that lighting?
Well, that's probably lighting over there. You'll see some Cherenkov when we moved.
Wait, you're going to want to wait and see it up close.
The bundle here, you'll probably see it, but there is a blue glow that'll be around the fuel itself.
So is this a crane operator, like actually grabbing things?
That's right. You'll see it when we go over the next bundle, but there's like an open claw, And then there's the camera is
All this is a submarine crane, which is cool.
open claw, and then it'll sit down on the bundle and it'll latch onto the bundle.
Really? Okay, cool. And and all these are different fuel. Man, that's crazy. So it's just like the claw game almost. They're just kind of putting things in the little slots.
Yeah, they've all got specific places.
A little easier than the claw game. You really don't want to drop a fuel assembly. But there's all sorts of interlocks, mechanical interlocks within the crane mechanism to prevent you from doing that, and also to prevent you from latching on if you got, say, a bad angle or something like that, all to prevent dropping a fuel assembly.
It's supposed to go. We keep very close track of where everything's at, and there's a lot of, I guess I'll say poisons, especially in the spent fuel pool, where we make sure that we can put the fuel and the fuel stays subcritical at all times.
Oh, so that.
All right, so he's talking about like putting in boric acid to ensure that you have adequate shutdown margin. Subcriticality is another word for that. Basically, you are so far below starting a nuclear reaction by that much in terms of reactivity units. Basically, to make sure you're shut down by way more than the minimum requirement to remain shut down. And of course, as you're moving fuel out, your shutdown margin is going to go up because you have less fuel that you could possibly have to take a reactor critical.
So this is the reactor?
This is the reactor.
And then this is the spent fuel pool.
Well, the crane's going over to the reactor at this point in time. It was in the spent fuel pool. So now you'll see it come over the reactor here.
Whoa, that was a cool reveal. That was pretty neat. So this is what the reactor looks like.
Yep.
Okay, so I guess this is a question I have. So we've got cameras.
And this is typically what you see. Everybody has these cameras logged in on something because everyone is tracking the refueling part of the refueling outage in every department because there's certain things that you get handoffs for so you can do certain jobs. Once the core is fully defueled or fully refueled, various things you need to do in other parts of the plant. So everybody at the plant is watching this.
And Philip, you were saying don't use like non-cotton fabrics. You're saying that's bad, right?
Not necessarily bad. Synthetic fibers tend to have more static electricity.
And static safety, sure.
Static is what radon gets, it will adhere to it.
So when the radon attaches to it, I'm not going to be able to get this out because the RP won't let me.
Yes, so something that really has nothing to do with the reactor itself, but it can affect the sensitivity of the instruments. And some of them have radon rejection, like I've noticed sometimes when you walk through those portals that scan you, it'll say, hey, you're clean thanks to radon rejection or something like that. But even that's not 100% foolproof. So you want to try to avoid radon. And really, worst thing that'll happen is they would take your clothes, they would examine them, make sure it's not contaminated with everything else, and then give them back to you. I even remember when I first started working at the nuclear plant, my first day at there, I didn't into the radiological controlled area. Yeah, they took my pants and I had to wear some modesty clothes for a couple hours until they gave them back to me.
It'll set off the radiation detectors, and then you can, most of the time, you can just let it sit for a little while and it will decay and you can get it out. It might be the next day, but
that radon is all naturally occurring. That's
not from the plant.
That's not us.
So the RP personnel.
That shows you how conservative we are at the nuclear plant. Is we will pants you if you get a little bit too much background radiation due to static cling.
I learned about in the safety training, the people that have to scan you so that you can come out, they have to make sure that you're clean, and so a lot of times radon is the stuff that gets on your bag, and that'll set off their detectors and you can't get out.
Yep.
Right.
Okay. So
and same thing with your clothes. If you wear synthetic fibers, polyester or nylon, stuff like that.
That was what got me. I wore polyester. That was my amateur nuclear noob moment of my career.
Same thing.
Got it.
You're about to pull a fuel bundle out of the core, and I think you'll actually see this rank-off effect here when it comes out.
Really?
All right, so we're defueling. Okay, so the outage just started. That actually makes sense for the timing of this video, because refueling, trying to time that right, or I guess reloading the core, I should say, is going to be challenging if anything changes with the outage schedule, but going and having him be here during core offload makes more sense, because that date's a lot more predictable.
He's trying to grab it first?
Yep. What they're doing is they're on the bundle, And they've each got unique identifiers, serial numbers. You can kind of see it right here. So they're going to verify that they're on the right bundle. And then now he's sitting on it, and then he'll latch onto it, and then he'll make sure that he's got a good hold of it, and then he'll bring it up.
This person has a peer checker and an independent verifier to make sure they're on the right spot, and the SRO supervisory oversight, and a reactor engineer following and measuring counts during each of these operations to make sure you don't get any sort of flow or radiation anomalies. One of the most supervised jobs there is.
Used to do, isn't it?
I did this for a little while, yeah.
You were, what do you call this person?
I was the reactivity manager over the fuel handler.
Fuel handler, okay, cool. So he's securing?
Yep.
And is there some video we can get of this?
Absolutely.
Are they recording this, you think?
They are.
And so now he's flying the bundle. Or she, whoever it is.
Withdrawing it.
There's just a rank-off effect right there.
Oh, yeah. So how far above the pool will we be?
See it really well in the hole right there that was just vacated. So we're about to head to the plant. We're going to swing by RP. They're going to give us a RWP, a radiation worker permit. We're going to sign in to go into the plant. We're going to understand our dose limits and all that type of stuff. Then when we get up, I'll take you up to the floor. And then when we get up to the floor, you and I are going to change the jobs that we're doing because we're going to go out on the bridge. So you and I will have another RWP we'll log on to.
About foreign material dropping into the pool.
Yes.
And so I'm hyper aware of
There is you are absolutely required to take training on that if you're going to be going in any of these FMEA, so that's for material exclusion area. And this is going to be the FMEA 1, which is going to have the highest level of controls, which makes sense. I mean, after all, you're over the refueling cavity. Sometimes at various stages of the turbine outage, that can also be labeled an FMEA 1, but someone's going to log everything you take in with you. The FME monitor will log everything you have.
Right now.
It's one thing we do. I mean, it's taken weeks to get you in here, and the only thing we've done is really just train you for a week pretty much before we got.
And that is the nuclear industry in a nutshell. Train you for weeks, provide a bunch of briefings from each independent group. So your job brief, your radiological work brief, your FME brief, your plant status control, which is about bumped hazards, and making sure you're manipulating the correct component, and all those briefings and organizing times can take a couple hours, and then the job takes maybe less than one. Yeah.
Right.
Yeah, absolutely.
We want to make sure you're prepared.
Yes and yes.
How are you, buddy?
The login area.
That's an interesting fellow right there.
Yeah?
He's our valve guy.
A valve guy?
Yeah.
You have a whole guy just for valves?
Yeah, we have a couple.
Probably have a whole department just for valves, a whole subset of mechanics that just work on valves. There's a lot of valves.
Guys just for valves, but he's our lead guy for valves.
There we go, lead valve guy.
We've only got one drum right now. I'm like, well, that's a little different than tank.
Can I see your tattoo real quick?
Yeah.
That's awesome. That's cool. Thanks. Pretty good.
Guys.
I think this is RP?
This is RP, yeah. This is our briefing station before we head out into the plant to make sure we understand what RWPs we're getting off.
That's good.
So when you go to log in, it's going to ask you to scan the front of your dosimeter first, scan that barcode. Yep. And you're going to scan, it's going to say scan the back, it'll be that barcode. It's going to ask you for a work order number. Type this number right here at 125-129-292. Then it's going to give you a drop down box. You hit the little arrow, and that's going to be the only number that's available. It ends in that 121. Okay?
Yes,
that's
sir.
going to be y'all's RWP. It's going to get y'all up to the refuel floor, traveling through Unit 1. Be able to take y'all in the office. You can check in up there. Now, when you get up there, make sure you let them know your set points for your RWP. It's 5 millirem dose alarm and 40 millirem per hour dose rate alarm. That's fairly low to be going on the refuel floor. So that would determine where they're going to allow you to go, or if they want y'all to be on a different RWP with higher set points, okay?
That's a good point. Confirming where the alarms is, because just because your dosimeter goes into alarm, that doesn't mean, oh my goodness, something scary and horrible happens. That just means you exceeded what you briefed for. And radiation protections would come in and get you, would evaluate, make sure you're okay, and the radiological conditions can change a little bit depending on where you're at in the outage. So that's also an interesting point. The other thing is, and this is a little different compared to where I worked, they mentioned walking past Unit 1. At the plant I worked at, they were separate. So separate reactor containment buildings. And they were probably a good 300, 400 meters away from each other as far as where you'd even go. And there'd even be a bunch of signs that would say plant status control area, this is the operating unit. That is to say, don't go take stuff apart in this unit as one final little catch-all, even though you're briefed a zillion times and they're physically separated from each other. So this introduces a bit of potential risk of walking by equipment that you don't necessarily need to walk by. So it's definitely one of the trade-offs of keeping your units right next to each other.
5 and 40? 5 and 40. Okay. Just make sure that the technicians that you talk to up there know that.
Yeah, I will.
All right.
Let's get you one of these.
So we can grab any of them.
Well, we want a smaller one. We don't want a screamer.
Screamer, the ones that track your location.
A screamer meaning a loud one?
Yeah, so if you're in like a high noise area.
Oh, okay. A loud one. Okay, I've actually heard it referred to. There are some that track your location, but those are only on certain higher radiation areas. Different people call things different things, I suppose.
So we're going to go to a white trip ticket area. White. Anyone that says white is fine. Put your dosimeter in there first.
Yellow for high radiation area.
There you go. Yep. Yep. And then it's going to ask you to scan the back. Now this is where you pull up your view your RWP. So click view RWP. This is what we talked about earlier in the training, right?
Mm-hmm. So every worker does this.
You are granted access to the RCA.
That's a pretty big deal.
And then you're going to put that right next to your DLR.
Sounds great. Here we go, about to go in. So you've been saying for years you didn't ever think this would happen?
No, I really didn't think Bill would pull this off.
So we're actually about to do it.
I am just as surprised as AR that a site would be willing to spend this much resources to do this. This is fascinating.
It's a pretty big deal. Bill, are you proud that you pulled it off?
Let's not give me all the credit, because if this goes awry, I don't want to be the one that goes down, man.
It would have taken a lot of sign-offs from a lot of different departments.
But it's a pretty big deal to be able to take a camera into a place like this.
It is a huge deal, yeah.
That's what I'm talking about, man. Get in there.
It's exciting. Is that Kevin?
Yeah.
All right, so here's what we're going to do. We're going to go in the RCA. You're going to put your dad on here. Philip will go in last. Just make sure you're all good. You get the green light?
Yes.
Go in.
Put them in right there.
Now you got your...
These turnstiles are the exact same way at the plant that I worked at.
Hard hat?
Yes,
safety
sir.
glasses?
Yes,
hearing
sir.
protection? DLR? And your dad, right?
Yes, sir.
Good to go.
Great. Currently, I have 0 millirem.
That's good. That's
We're going to an industrial environment so it can get a little loud, okay?
Yes, sir.
All right,
Hearing
all ready?
protection.
Let's go.
They're showing all this traversing through the RCA. Wow.
So we're in the RCA now.
We are actively in the RCA, that's correct.
It's very...
So all of the primary support systems that are going to be located near the reactor are in the RCA. This is in contrast to, say, the turbine support systems. Though that being said, especially in a boiling water reactor, things can turn into RCAs if conditions become prevalent that there's, say, elevated dose in the area for some reason. There's a lot more radiation monitors in the secondary part of the plant for a boiling water reactor than they are within a pressurized water reactor. Though there's still a fair bit in a pressurized water reactor. We had quite a few in the plant that I worked at as far as radiation monitors in the non-nuclear part of the plant. Now, in this part, there's radiation monitors everywhere, which is good.
It is.
Video.
That low dose waiting area is a place that has been surveyed and been determined to be low, so you're not sitting in an area if you're just waiting and picking up dose unnecessarily.
Okay, so what I'm about to take you into is the secondary containment area, right? You'll notice that there's some locked doors and everything, like watertight doors. We do this intentionally because this is our absolute last means if something bad happened. That's where we keep it all. We keep this area at a negative pressure just to make sure we keep all the containment products inside secondary containment if something were to have happened.
In contrast, the control room is kept at a positive pressure to prevent anything from going into it. So this is the opposite.
So that's why you see the doors like
So that's an air and a water door.
a flow tight. Yeah, it's not really an air door. It's mostly a water door.
Okay.
Yeah, that's going to be watertight. In airtight, you would go through something called like a personnel airlock type door, which is what the primary access to the main reactor containment building at the plant that I worked at.
Do we have to badge in to go?
Yeah, we're going to have to badge in. So I'm first in.
Yep.
And we're going to walk up to the elevator through the operating spaces because there's less traffic over this way.
And before we go any farther, when you see the floor drains, don't step on those. So they're a lot of times contaminated.
Yeah, they're usually marked with radiological symbols on them and coded so you see right where they're at.
So be looking for floor drains.
Like that one right there. And another one.
So we have 185 control rods. There's 185 of these accumulators, which will assist the control rod to enter the vessel in the event of a scram.
Got it.
Yes, because gravity is not helping you since you're going from the bottom up, compared to the pressurized water reactor, which doesn't need these. You just fall in.
So they're individual pressure tanks with check valves to maintain pressure.
Effectively, yes.
Okay.
Mm-hmm. Well said.
So it's contaminated just because water has gone down into it?
At some point in time. The surface is most likely not from where we're at, but inside those drains, there may be some contamination.
I see.
We don't know, and getting into the drains and free-releasing it is very difficult, so we just say, stay out of it.
Don't touch it. Got it. I'm getting no dose.
That's a good thing.
Go up
I appreciate him doing it for the camera because a lot of people, there's a lot of misconceptions out there that think, oh, you get all kinds of dose at the nuclear power plant. I never got much throughout my career. Of course, engineer, control room operator, supervisor, and then manager, you typically wouldn't as much, but still, a lot of people think you get a lot of dose.
Fourth elevation, we'll pick up our C-zone clothes that I suspect they're going to ask us for, and then we'll head up to the floor.
Okay. What RP you on? Or what? How do you say RWP?
RWP.
What RP you on would be what radiation protection are you on?
5200022.
Is that how I would say that to you? What RWP you on?
Yeah, that's typically how it goes.
It's more like how long till lunch? That's what we normally talk about?
Yeah, something like that.
This is a big motor.
Yeah, they're abandoned in place at this point in time. That's how we used to control the speed of the recirc pumps before we had static control. So we've moved over to the
Yeah, you'll see some big things abandoned in place because the engineering cost could be too much to effectively remove it because of all the lineups associated with this component.
But these are some big old motor generators.
It's easier just to leave them there.
Yep.
Yes. Abandoned in place, usually associated with the phrase, the engineering costs would be staggering.
In place. Interesting. So we're going to dress out here?
No, we'll take our stuff up to the refill floor and get briefed up there, but we're going to grab our booties and everything here.
I was going to say, you wouldn't want to dress in a really confined... I mean, this doesn't meet the definition of confined space, but it doesn't exactly look like the best spot to play dress up.
Okay. Are you getting one for each of us?
I can, yeah.
Can you hold it? Oh.
I'm scared to touch anything.
Good. Stay that way.
Stay that way?
No.
Yes. That is, well, scared. Don't be scared, but be hesitant to touch anything. And that's good plant status control behavior. It's called having reverence for the plant and treating every component with the respect that it deserves because, hey, everything you see here maintains this awesome thing that is a nuclear power plant.
I have no clear plastic. Do you have any clear plastic?
I have no clear plastic.
Thank you.
Thank you.
And that is an example of an FME control. No clear plastic beyond this point, because that stuff is difficult to spot. Yeah, again, so many signs.
Your license? Your license?
How y'all doing?
Good, how are you?
So you're the RP?
Yes, sir.
If there's one thing I learned in that training, is to say Mother May I to you before I do anything.
Oh, really?
Well said.
FME is gonna love these guys. Yeah.
Yes.
We've been briefing them up. This will be my test for them.
Yeah, right now.
What do you think they're going to do to me?
You're gonna get the rigs trying to get all that stuff out of the bridge.
You think so?
Yeah. Trying to get that.
Yeah, all the FME tie-offs for all this camera equipment.
Yeah.
You got to see the cameras. Good luck.
A lot of straps.
A lot of straps. Yeah. What's your name?
Trenton.
Trenton, I'm Destin. Nice to meet you.
Destin.
I didn't like that handshake. Let's do that again. That's a better one. How long you been here? In terms of...
I like how wholesome a lot of this is, and that really, it does come down to a lot of interactions in the nuclear plant.
Yeah, nuclear.
2011.
Really?
Are y'all going out too?
Just me and Destin will be. Yeah, we're gonna take the other guys up to the crow's nest.
Yeah.
And Destin and I will be out on the bridge.
So you're RP.
Let me get your ID. Let me get your ID.
18504.
Always be nice to people on the elevator. They might be your RP later.
Now I've got to ask you what your RWP is.
My RWP is...
Don't start stuttering now.
121? Is that it?
Here we go. You get the sheet.
That's my work order. It's...
Yeah, I was gonna say, you don't have to memorize it, just keep it written down, but yeah, you gotta know what your RWP is.
125, 129, 292.
That's your work order. You're right. Your RWP is 121.
Yeah, 121's my work order.
Your RWP.
RWP. Dadgummit.
What's your ID number on that?
My ID number is 37467.
So you'll be on 25, like I said, you'll be on 25 2000 92. The dose alarm is 60 millirem.
Okay.
The dose rate alarm is 250 millirem per hour.
Alright, this is what our RWP looks like. When you go to look at it, you got your description. This is for refuel floor activities. It's for high radiological risk, so this will gain you entry into high radiation areas, even though we don't have...
That makes more sense, putting you on that type of RWP for getting on the refueling bridge.
One post where y'all will be at, but just in case moving things throughout the water, high radiological risk is a possibility, which is why your dose alarm will be the 60 millirem. So the area where you'll be at on the bridge. So if you look over there, to the
orange
top
part?
right panel, yes. If you look at this top right panel here.
Those are going to be the FMEA boundaries, those orange bits, and they usually have something that says such on the actual barrier.
Bridge. This is the bridge. You see all these people on here?
Yes, sir.
So that's where y'all will be at.
Yes, sir.
So dose rates up there are about 1 to 2 millirem an hour. So that's where we come to our dose rate alarm. Your dose rate alarm is set to 250 millirem an hour.
That's a good
on
bit
the
of
bridge,
dose.
you shouldn't get close to that at all.
Because of the water.
It's the water. Water's your shield.
If you're setting off that alarm, then something crazy just happened that would probably indicate either your EPD's broke or you might need to start getting people out of there.
Your mediator. We have stop work criteria. In the event of a dose alarm or unanticipated dose rate alarm, will notify RP.
That's a microphone.
Oh.
I just having a hard time hearing you.
Oh, there we go. Yeah, stop work criteria. In the event of a dose or a dose rate alarm, immediately notify RP. Stop work, we'll leave the area. We have air monitors on the north side. So if you hear those go off, and you'll hear them go off, that means everyone in the C zone or on the floor will evacuate, and we'll help that transition, and we'll leave the floor entirely.
Will RP be on the bridge?
We will have RP in the zone, and they will be covering the bridge. We have telemetry.
Detectors
so we
on a
can
stick.
constantly monitor the dose rates in the area. So right here, you see these little dose rates.
Yes, sir.
So that's for inside the 360 platform, and that's for on the bridge. So if you look back to our screen over here, you'll notice on the left camera, there's a 360 platform here. So we have RDS 31s monitoring the dose where the workers are actively working in the 360. So this just helps us see the progression of dose rates in the area from afar. That way we can let anyone know, what's going on.
So you've got instrumentation right there, and we're going to be on the bridge right there where they are, correct?
Correct.
And then, so you're monitoring it in real time, and because the RWP is active, you know that we're out there.
That's correct.
Okay.
Yeah,
Okay.
so everyone's covered all the way around, both ways and backwards.
Sounds good. And so now I'm at 0.1 millirem an hour, which is nothing.
Right, and now you're about to sign off out here and sign on to, because you probably come up on what, 71?
It came up on 121.
121. So we're going to sign on to 252.000.92.
Yes, sir. And then my rate alarm will go up.
Right, so your set points will change. You'll go to a dose alarm of 60 millirem and a dose rate alarm of 200.
So essentially what we have here is concentric radiological work zone. So he had the lower dose one that he was able to make it to here, but since he's going to go on the bridge, he needs to have one with higher set points so you don't needlessly set off alarms. And so you know he's the sort of person that his job, his work permit is set for the appropriate level for the hazards that are in the area.
50 millirem an hour.
Cool. Thank you. I appreciate it. What was your name?
Christian.
Nice to meet you, Christian.
Nice to meet you.
Yeah.
All right, now that you stop back by this window, you got a full brief on it. We do a reverse briefing.
Yes, sir.
Nice.
The dose alarm and dose rate alarm, we typically what we do is say, hey, what's your dose alarm? You repeat back to me what the dose.
A reverse brief would be you briefing the RP guys, and we've done this in the control room with pre-job briefs. For a task that is done almost entirely in the field, the plant operator or the maintenance technician would come to the control room and tell them what they're going to do, what the operational impact is, what their mitigating actions are, what their backout criteria is, and basically everything you need to know from your perspective in the control room to ensure this job is conducted safely.
Which would be 250. And then I ask you, what's your dose rate alarm?
60.
And you say 250.
It's 250 millirem per hour?
250 millirem per hour. Yes, that's correct.
What's my limit dose? Is it 60? It was 60, so I said that backwards. Okay.
Yeah.
So the dose rate alarm is 250, and the dose limit is 60. Yes, sir. Millirem.
One's a millirem and one's a millirem per hour.
Yep.
Yes, sir.
So the dress out is going to be a full dress out with the single dress out with the hood.
So single dress out, and that's really for protection against contamination rather than radiation. There are some jobs that are pretty dirty that you actually wear double the number of protective clothing. So that's what he means when he says single dress out, not doubles.
On the bridge, and that's to protect you because you're going to go into a contaminated area. Contamination levels in the area on the bridge is less than 1,000 dpm per centimeter square, up to 2,000 dpm per centimeter square. So low level contamination, minimal dress out. That would be. We have several different dress outs, so this would be the minimal dress out.
So we're not going to be quite to the level he is, or is it going to be the level he is?
It's the same dress out as
you want a hood, not a skull.
Yeah, that's level 1, if you will. There are some jobs that I've seen where you essentially could just wear a lab coat for very light amounts of contamination, but most things you see today that involve going in the reactor containment building, you're going to need the full set of PCs, and that's considered the low level of dress out.
Yes. Okay. We'll have to go get a hood.
Okay.
Appreciate it, guys.
Okay. So my max is 60, my rate is 250. It's a single, and then you do want to send hood and skull cap.
Right. And then it gets a little tougher, 80% of 60.
80% of 60 is 40. Hold on. It's 60 minus 12, which is 48.
48, yeah.
There's a lot of math under pressure here.
48 is when I need to start looking for the door.
Right. Yes.
Okay.
So that'll be the time you have to evacuate.
Sure.
So other than that, Christian briefed you on the dose rates on the bridge, and now you have the information for the contamination levels on the bridge. You did a reverse briefing. Is there any questions or concerns?
I have a question for you guys. What do you guys think I'm going to get dose-wise while I'm in there?
You're around about 0.5 millirem per hour.
0.5? What do you think my total is going to be? It's going to be based on time.
It's going to be 0.5 millirem per hour, and you're going to be in there an hour.
Okay.
Yeah.
Okay. Cool. Thank
That's
you.
how long it takes you to get in and out.
You're welcome.
You're not going to be in there an hour.
Not going to be in there now? Mr. Summers, right?
Yes, sir.
Yeah, thank you, Mr. Summers. Appreciate it. Thanks, Christian. What was your name?
Jonah.
Jonah? Nice to meet you guys.
All right.
Sorry.
I like that they included the pre-job brief as part of this. That's really shows you what the sort of things you see in the nuclear industry. We're going to go ahead and call it a part now. Please stay tuned for part 2. This is some really interesting stuff.